Welcome back. So far, we've explored how you entered robotics and uncovered some of the realities that every robotics engineer eventually experiences. Now it's time for what many people look forward to most: your stories from the field. Every robotics engineer has moments when everything goes according to plan and moments when absolutely nothing does. Let's start with a project that almost failed.
There are quite a few. One project I remember very clearly involved building an autonomous mobile robot for a large warehouse. Its job sounded simple: pick up a storage container from one location and transport it to another without human intervention. We tested the robot for weeks inside our lab. Everything worked beautifully. Navigation was smooth. Obstacle avoidance worked perfectly. Battery performance exceeded our expectations. We were confident. Then we deployed it inside the customer's warehouse. Within 15 minutes, the robot stopped. Not because anything was broken, it simply didn't know where it was anymore.
That must have been stressful. What happened?
The warehouse looked completely different from our testing environment. Our lab had fixed furniture and predictable lighting. The warehouse constantly changed, pallets were moved, forklifts appeared unexpectedly, temporary shelves were added. Even the lighting changed throughout the day. The robot's internal map no longer matched the real environment. Its confidence in its own location gradually decreased until it decided the safest action was to stop. At first, the customer thought the robot had failed. In reality, it had made the safest possible decision. It refused to continue because it wasn't certain where it was.
That's actually reassuring. Instead of guessing, it stopped.
Exactly. One of the first lessons in robotics is that uncertainty can be more dangerous than failure. A good autonomous robot doesn't pretend to know everything. When confidence becomes too low, stopping safely is often the correct decision. That experience completely changed how we designed localization and recovery systems.
You mentioned earlier that robotics often teaches humility. Was that one of those moments?
Absolutely. Technology behaves differently in the real world. Every deployment reminds you that reality is the best testing environment.
Let's talk about something a little lighter. What's the funniest robot failure you've ever experienced?
This one still makes our team smile. We built a small indoor delivery robot for an office environment. It successfully delivered documents between departments. Everything worked perfectly during testing. On demonstration day, the robot started confidently, then spotted its own reflection in a large glass wall. Its vision system interpreted the reflection as another robot approaching. Being polite, it kept trying to give way. Unfortunately, every time it moved, the reflection moved too. For almost 2 minutes, two robots politely avoided each other, except one of them didn't actually exist.
I imagine everyone watching was trying not to laugh.
Exactly, the customer laughed, we laughed, then we fixed the perception software. That demonstration reminded us that robots don't understand the world the way humans do. They only understand the information their sensors provide.
Speaking of sensors, have you ever had one create a really unexpected problem?
More than once, one outdoor inspection robot occasionally believed there was an obstacle directly in front of it. The strange part was there wasn't. We inspected the LiDAR, no fault. The camera looked fine. Software logs showed nothing unusual. Eventually, during another field test, we noticed something. Early every morning, sunlight hit the LiDAR sensor at exactly the right angle. The reflected light produced occasional false readings. The robot wasn't malfunctioning, it was reacting to incorrect information. We redesigned the sensor housing, adjusted the filtering algorithms, and the problem disappeared. That project reinforced something we tell every new engineer: always investigate the environment before blaming the software.
That's a valuable lesson. Now let's move to one of the questions everyone was waiting for. Have you ever worked on a dangerous deployment?
Yes, one project involved autonomous inspection inside an industrial facility where people couldn't easily enter because of safety concerns. The robot had to inspect equipment, collect images, and return without human assistance. The biggest challenge wasn't navigation, it was reliability. If communication failed, if a sensor stopped working, if the robot encountered an unexpected obstacle, there wasn't always someone nearby to help. We spent months testing failure scenarios. What happens if one sensor fails? What if battery levels drop unexpectedly? What if communication is temporarily lost? How should the robot recover? Those discussions became just as important as writing software. Real robotics isn't just about making robots work, it's about making them fail safely.
That idea of planning for failure seems to come up again and again.
Because failure is inevitable, ignoring it isn't. Professional robotics engineers spend a surprising amount of time asking what happens if something goes wrong. Designing those recovery strategies is often what separates reliable robots from impressive demonstrations.
Let's talk about debugging. What's the strangest software bug you've ever encountered?
One robot occasionally rotated in circles for no obvious reason. Not every day, only occasionally. Our navigation algorithms looked correct. The motors worked perfectly. The sensors appeared healthy. We spent several days investigating. Eventually, we discovered that two software modules were using slightly different coordinate reference frames. Both systems were individually correct. Together, they disagreed about which direction was actually forward. The robot wasn't confused, our software architecture was. One small configuration error created days of debugging. It taught us the importance of standardization and careful systems integration.
That's a great reminder that robotics is really about systems rather than individual components.
Exactly. A robot may contain cameras, lidar, motors, batteries, processors, wireless communication, navigation software, perception algorithms, and artificial intelligence. Individually, each component might work perfectly, but if they don't communicate correctly, the robot won't perform reliably. Integration is where engineering truly happens.
Have you ever had a particularly challenging customer?
Yes, and they taught us a important lesson. A customer once requested that we make a warehouse robot move much faster. Technically, we could, but increasing speed reduced stopping distance and left less time to react to unexpected obstacles. Instead of immediately accepting the request, we demonstrated the trade offs. We ran simulations, we collected safety data, we compared productivity improvements with the potential risks. By the end of the discussion, the customer realized that reliability and safety were more valuable than maximum speed. Sometimes engineering isn't about saying yes, it's about helping customers understand the consequences of different decisions.
If you could summarize all these experiences into one lesson for future robotics engineers, what would it be?
Never assume, observe first, measure carefully, collect data, test repeatedly, then make decisions. Robots teach patience. Every unexpected behavior is an opportunity to understand the system more deeply. The best robotics engineers aren't the ones who panic when something goes wrong. They're the ones who stay curious until they understand why.
I really like that perspective. Before we finish, one last question. After all these years, do robotics projects still surprise you?
Every single one. That's one of the reasons I still enjoy this profession. Every deployment introduces a new environment. Every customer presents different challenges. Every robot teaches us something we didn't know before. Technology keeps evolving, and as engineers, we keep evolving with it. That's what makes robotics such an exciting lifelong career.
What an incredible collection of stories. Today, we've learned that successful robotics isn't about avoiding every problem. It's about designing systems that can adapt, recover, and continue operating safely when the unexpected happens. In our next segment, we'll step away from dramatic project stories and spend a day with a robotics startup founder. From early morning system checks to robot testing, customer meetings, simulations, software development, and team collaboration, we'll discover what life in a robotics company really looks like. Stay with us.